figure it out. I got one coming, I see. Look at the letters, but messenger RNA carries instructions from the nucleus out to the cytoplasm. And the cytoplasm, after reading the messenger, transfer RNA grabs the correct acid and carries it to the ribosome. The ribosome attaches the acids together, producing a protein. Ribosomes are made by the nucleolus. Now, let's go back and see how you did and all. Okay. They all have what? Carbon. And how many bonds can carbon make?
4.
4. Good. Which two of those are organic?
A and B.
A and B just have kind of appetite. A and B are. Or B and A. How you do?
Never.
They never have what?
Never.
Well, I'm sorry. Yeah, they never have metals. I forgot. They never have metals. Never. That's when you want both with it.
Yeah.
Okay. I don't get that. Carbohydrates, lipids, or fats, proteins, and nucleic acids. I don't care. You can say fats or lipids. I don't care. The simplest carb is a what? Simple sugar and monosaccharide are synonymous. They're the same thing. So, then the most complex would be the starch, which is a polysaccharide. Starches are polysaccharides. So those two. Term carbohydrate means you have carbon atoms bonded to water molecules. Carbon to water. Carbohydrate. And that's why I talk about this one. Now if you look at these, which one shows H's always 2 to 1? A and C. If you're 2 to 1, you're water. B, that ain't 2 to 1, that's 3 to 1. That's a fat. D ain't 2 to 1, and neither is E. Those are all fats. So if you're 2 to 1, you're water. That's a carbon to the water. That's why I said the previous question, I thought that one from it. Alright. These are the ones I boogered up pretty good. Maltose would be C and C. That's why I tell you might use one twice. Both are glucoses. Sucrose would be
C and
of course, there's C again, but the B. I think my key says B and C because I try to get the order. Okay. And the one I really messed up was this one. And that would be B and
A. E.
Echo. Galactose has the word in it. I mean, how do you think? I see lactose in the word galactose. All right. And this dehydration synthesis, you remove water to build. So, bravo's the answer. You dehydrate to build. Pull out water, they join together. Bravo's the answer. And this one is doing that. It's taking 2 monos and making a di. So we call that anabolism. Actually, it is dehydration synthesis.
So
I'm pulling out the water.
A and D, right?
Yeah. And the next one, I reversed it and put the water back. Well, that'd be catabolism, and that is hydrolysis.
Oh, wait.
You put the water back.
What about that 20, the extra 20?
Already did that one.
You did
I just answered it. I just answered it. Where do you find the energy in the sugar molecule? The atom or the bond?
Bonds.
Only in the bond.
Okay.
Only the bonds have energy. You break the bonds, that's it. Alright? What stiff starch holds plants up? Cellulose. Can we digest it? No, we cannot. We can't digest cellulose. Which of those is not a string of things? Yeah, amino acids are not a string of things. Other ones, A is a string of amino acids actually. Starch is a string of monos, and nucleic acid is a string of nucleotides. Charlie's in.
B and C.
Well, I should go back and I'm going to make it become 31, 32, whatever. But the answers I'm looking for are either B or C. Usually most folks think of B probably. But C is also, we do use that to build. Those name tags on cells, Glycolipids are used there. Well, what are those?
Lipids.
Those are kinds of lipids. And which one is saturated? It's full. It's full. The A is. And which one is un? B is. There's room for more H's, so it's unsaturated. And because it can move around like that, it's a liquid at room temp. The one on top is like a person in two-sided pants. If you do sat and unsat, what do you say for meat? Sat. Butter?
Sat.
Olive oil?
Unsat.
Unsat. Avocado?
Unsat.
Unsat. How about canola oil? It's oil, right? That's a liquid, right? So that's unsat. Hey, watch out though now. The breast milk, highly saturated. Soybean, and the coconut oil is unique because it's saturated. I love it, but it ain't good for me. And most things I love are not good for me anyway. So what's the difference by that? Which ones are good for you?
B.
The unsaturated are good for you. What they do for you?
A.
They lower the LDL by raising HDL. That's good for you. You like it? HDL is good for you. Matter of fact, my next question came from that idea.
B.
HDL, Bravo is the one that's good for you. Saturated, what are they at room temp? Like lard, and they're solid. Unsaturated, they come from plants. Saturated come from animals. Unsaturated fats are, they're the liquids, because they have room to move. They're not full of H's. They don't dissolve in water, therefore they are hydrophobic. If you're hydrophilic, you love water. If you're hydrophobic, you don't like water. Steroids are lipids. They can pass through a cell membrane. That's why they're so powerful. They can go around through. Pesticides, by being lipids, can go right through the cell membrane and kill the pest fast. If they were water soluble, they wouldn't get in. They wouldn't get in the cell to kill them. So by being lipid soluble, they go right through the cell membrane and do its job. Go ahead. I saw you first.
What if you put that if they wouldn't kill the pest if they were water soluble? Is that okay?
Well, that's obvious.
Okay. Well, I mean, so
That's not why they're lipids.
okay.
What if you
What do you have?
Well, we just put, it goes through the cell membrane.
That's good. That's what I said.
About pesticides are
What if you put so?
they can store toxins like your lipids store.
That's not why that's not why we make them out of it.
So no.
We make them out one reason. A lipid thing can go through the cell membrane. I want to carry a poison into a cell. I don't dissolve it in water.
So you're looking for it will go through the cell membrane.
That's
That's
how you kill the organism.
Okay.
You can't get in there, you can't kill it. Okay?
Hey,
These came in order, basically. Did y'all notice that?
Yes.
I didn't know, I hope I wouldn't fool y'all, but primary, secondary, tertiary, quaternary, so they came right down the line. I might leave them that way, I don't know if I'm or not. The only thing that can change your shape, they open and close. Proteins. Proteins can change your shape. Enzyme catalysts, you could not break down your nutrients if you didn't have the enzymes. It would take you too long and you would die waiting for them to break down. They speed up reactions, therefore the food I ate this morning, I can use it today. Without the enzymes, it might take me months. I'd be dead. Yes.
what if you put chemical reactions?
No.
What if we said it like speeds up metabolism?
That's good.
Okay.
If you mention speed up,
Gives us the boost.
that's what they're for. They speed up.
Okay. Good.
Got any question?
I put breakdown to build up, like to build the energy for that day.
Break down to build up. I don't think that's gonna work. When you said speed up metabolism, why don't you stop right there? That's the best answer. They do speed up metabolism. Therefore, the food you eat, you can use it in a timely fashion. Without enzymes, the food you eat, you wouldn't use that stuff in time to keep you up dying for starvation. That's what they're for, to speed up metabolism, not just reactions.
Oh, wait, so can we put speed up reactions?
Yeah, that's what I said.
Well, you said, no, go on.
When I say metabolism, that equals reaction.
Okay.
Okay. The ending is ASC. ASC. Ene is a protein, iron's a protein, OS is a sugar, ASC is an enzyme. And that word there showed it to you. Polymerase, if you're making polymers, if you're making chains, then what are you? Anabolic or catabolic?
Anabolic.
You're anabolic. You're building something. All right. Which one has ribose?
DNA.
RNA. R, you know, that should be an L. Which one's a single strand? RNA. Which one has a helix shape? DNA. Which one is double? DNA. Which one's bigger?
DNA.
RNA.
What?
Uh-oh.
DNA.
Think about it. You have ribose and deoxyribose. What deoxy means? If I take ribose,
Minus
I
an
pull up
oxygen.
and make it smaller, I have then produced deoxyribose. Ribose is one oxygen bigger. So to make DNA, I remove one oxygen for RNA, and it becomes deoxyribose. So ribose is larger, just about a tad.
See, that's confusing because, like, you know, you say like the RNA is a single strand, and then you say the DNA is a double strand. So that automatically
Sure.
makes you think it's bigger.
So you did that on purpose. That was intentional trickery.
I can see your point there, though. Let me make a note to myself.
I did finish it.
So does that mean we get it right if we put DNA?
Yeah, I'm gonna let it go. Okay, I need to say the larger sugar of the two. So what I was first, and I will make a change to make it so larger of two definitely. DNA is a larger molecule, but the sugar itself. Well, I was thinking about sugar when I made the question, but that's ambiguous. I understand that. I know what you mean by saying DNA. It's bigger.
I even asked that question. I was like, what did you mean by the larger than two?
Yeah, but I'm gonna rephrase that to say which is the larger sugar of the two, and that would solve that problem. I want RNA as the answer for the question because it's bigger. Because to make DNA, I got to pull oxygen from RNA. When I pull oxygen off, it becomes DNA, which is one oxygen smaller. Now, which one contains? Well, there's deoxyribose. That means take ribose, take away one oxygen, and you have deoxyribose. That's why it's smaller. The DNA is smaller as far as the actual nucleotide. And which has the U
RNA,
and the T?
DNA.
There you go. Every bit is useful? No, there's some junk segments that don't mean anything. So the answer is false. Some of it is just simply crap that don't get used to make anything. But think what happens is that you may have been in the sun too long and the sun messed up some DNA. And what happens, your own body will... What's it mean when you get locked up away from people because you're sick? What's that mean?
Quarantine.
But it quarantines this. They'll take that bad segment and just kind of shove it in the back corner. That would be that's your junk DNA segment that are never used again. Now, we just did those.
What was 73 real quick?
You hook together acids, what do you make?
Protein.
A protein. And the last one, you should have wrote down the word ribosome. Ribosome. That's the 2 units of a ribosome.
For 74, I put nucleus instead of nucleolus.
No, it was made by the nucleolus, not the nucleus. Made by the nucleolus.
What was 77?
On what?
The first two.
Messenger RNA carries the instructions out. Transfer goes and grabs the amino acids.
Thank you.
Messengers and transfer. All right, would y'all go and get my 2 law